Hi, Year 12s. I hope you've had a really good holiday. In this video, I'm going to cover the last part of the holiday homework, which is exercise 1G in the Cambridge text, looking at the 5-number summary and box plot. This is all material that you've seen in Year 11, and my purpose of doing this video is to help you refresh your memory if you are feeling rusty and you had trouble following what was in the textbook. So let's get underway. I'm going to start with the 5-number summary. It's a list of 5 numbers. The first one is the minimum. The second number is Q1, otherwise known as the first quartile. The third number is, we often label it capital M. This is the median. Then we have Q3, which is the third quartile. And then we have the maximum. Now, remember, the minimum is the smallest value, and the maximum is the largest value. And the median is also called the second quartile. So if I have a data set that's ordered quartiles, divide a data set into quarters, approximately. So whenever you hear the word quartile, think quarter. So this means in any data set, approximately 25% of the numbers will lie between the minimum and Q1, Q1 and the median and the third quartile, and the maximum. Now, prior to this video, you've already seen some examples of how to calculate the median and how to calculate the quartiles. This page is a little bit abstract. Wouldn't it be nice if we could represent this visually with a picture? And we can. And the most common way of doing this is to use what's called a box plot. So, you've seen box plots in Year 11, and hopefully in Year 9 and 10 as well. So let me show you where the lines are. So, in every box plot, you may or may not have some dots to the left and right. These dots are called outliers. Outliers are, as the name suggests, values that are kind of special because they're very far away from everything else. So we kind of almost, we sometimes want to exclude them when we're doing our analysis. Okay? I'll tell you in a moment how we define what an outlier is. Most of the box plots you will look at won't have outliers, and they will contain the box in the middle, and then they'll have lines coming out on the left and right, which are called the whiskers. So Q1 is on the left, the median is in the middle, and Q3 is on the right. And maybe I'll give these some numbers. So maybe this is the number 10, and this is the number 100. So conventionally, when we go from left to right, the numbers are getting bigger. So if you're getting bigger towards the right, Q1, which is smaller, will be on the left, and Q3, which is bigger, will be on the right. Now, these lines coming out of the box. These are called whiskers. And you may be wondering, where's the minimum and where's the maximum in this box plot? Well, because there are outliers, this value here is going to be the minimum, and this value here is going to be the maximum. If there were no outliers, then the minimum and maximum would be at the end of the whiskers, so here and here. Okay, so it depends on the box plot, but you want to consider outliers when you are asked for the minimum and maximum. So, 5-number summary has the min, Q1, median, Q3, and max, and you'll see that most of those numbers appear in the box plot, particularly Q1, the median, and Q3. You can always tell where they are. And so in a box plot, you immediately get a picture of where the middle 50% is, because I have approximately 25% of values between Q1 and the median, and approximately 25% between the median and Q3. Now, we define another statistic called the interquartile range, the IQR, and we define this to be the difference between the third quartile and the first quartile. So that means Q3 minus Q1. So on this box plot, the interquartile range would be this gap here from Q3 to Q1, and this would account for the middle 50%, approximately. Okay? So without a box plot, it's very difficult to sort of visualize what's happening with Q1, Q3, and the IQR. But now that we've got the box plot, I immediately see 50% of values lie inside the box. And then the remaining 25% are to the left, this way, and the other 25% to the right. Okay, now let's talk about the outliers. As I hinted at previously, outliers are numbers which are they're far away. They're very different from the rest of the values in the box plot. And we need a common language, a common standard, or a convention so that we all agree on what is considered an outlier. So how far away do we have to be? And the answer to that question, which is accepted in the community of mathematicians and statisticians, involves the interquartile range. So we first need to define two quantities. The first one is called the lower fence, and the second value is the upper fence. So I'll explain what this means in a moment. So let's start with the lower fence. If I start at Q1, the first quartile, and then go down by the interquartile range multiplied by 1.5. So that might seem a bit strange at first sight, but just bear with me here. So we start at Q1, and then take away half the interquartile range, 1.5 of the interquartile range. So it's going to be somewhere around here. So Q1, and then take away 1.5 times the IQR. And then similarly, the upper fence is the same, but in the opposite direction. So I start at Q3, and then go up by 1.5 times the IQR. So start here, go up by 1.5 times the IQR, and my upper fence is going to be somewhere around here. You don't actually draw the lower fence and upper fence on the box plot, but I'm just showing them to you where they are to make this clearer. So, we define the interquartile range, we define the lower fence, and we define the upper fence. And this is how we define what an outlier is. An outlier is any value less than the lower fence or greater than the upper fence. So if you this is why I sort of just drew the lower fence temporarily for you. Here's the lower fence. Anything to the left of that lower fence is going to be an outlier. Conversely, if I'm at the upper fence, anything to the right of that value is going to be an outlier. Okay? So that's how we define an outlier. When you draw your box plots, you will be expected to show how you decided a value was an outlier. And you'll need to calculate the fence, and you will need to show your awareness of what is on this page. Okay, so you don't draw the fence on the box plot, but I just showed it to you to make it a bit clearer. You'll also find a similar diagram in the textbook. Okay, so we've done the 5-number summary. We've done the box plot. Let's do 2 examples where we construct a box plot by hand, including how we get the outliers. And I'll also show you how to do this on the CAS calculator as well. So here's our first example. I want to calculate the 5-number summary and draw a box plot for this nice and small data set. So what are we going to need? I suggest when you are drawing a box plot to start by finding the median. Now, I am going to assume that you know how to find the median. If you don't know how to find the median, you need to go back to the previous exercise and read the textbook. And if you still have trouble with that, then get in touch with me on Teams. But I'll run through it very, very briefly. Here I have 6 data points, and this is an even number. So the median is found by taking the mean of values n divided by 2 and n divided by 2 plus 1. Now, this is I should call it values in position n on 2 and n on 2 plus 1. This is a algebraic way of saying divide your data sets into half. So you'll notice there's no middle number because it's even. And then take the 2 middle numbers and then find the mean of those two. So here it's going to be 32 plus 36 divided by 2. And that's going to be 34. All right. Now I want to find Q3. So divide our data set in half. Q1 is the median of the lower half, and that's 28. So Q1 is 28. In the upper half, I find Q3 by taking the median. So Q3 is 38. All right, the IQR, well, I'm getting ahead of myself. The minimum is 26. The maximum is 48. So the 5-number summary and yes, you do have to write it out like that. It's 26, 28, 34, 38, 48. You need to write the numbers in that order. Min Q1, median Q3, max. Okay, and now that we've got that, we're ready to start making the box plot. But we're not done. We need to calculate a few more numbers. So the first number we need is the IQR, the interquartile range, which is Q3 minus Q1, which is 38 minus 28, which gives me 10. The lower fence is Q1 minus 1.5 times the IQR. In this case, it is going to be 28 minus 1.5 times 10. That's going to give you 13, because 1.5 times 10 is 15. Similarly, the upper fence is going to be Q3 plus 1.5 times the interquartile range. This time it's going to be 38 plus 1.5 times 10. And 38 plus 15 gives me 53. So, any number below 13 or any number above 53 will be an outlier. There are no numbers below 13 and there are no numbers above 53, so there are no outliers. Until I do the hard work of calculating the interquartile range, the lower fence and the upper fence, I don't know for certain if I have an outlier in the data set. So you always need to do this second part as well before you draw your box plot. Okay. So I'm going to need a new page, so just bear with me for 1 second. Alright, so our 5-number summary was 26, 28, 34, 38, 48. And there are no outliers. So I have everything I need to draw the box plot. So let's go ahead and do that. I'll need a scale. And I am going to do this roughly, that's okay. So I'm going to say go up by 5. Okay, let's start with the box in the middle. So I'm going to have a line at Q1. I'm going to have a line at the median. And I'm going to have a line at Q3. So 28, 34, and 38. Okay. I'll forget about the dotted lines. And now I need to do the whiskers. So my first whisker on the left is going to extend from Q1 down to the lowest value, which is not an outlier. Now, because I have no outliers, it's going to go all the way to the minimum, which is 26. My other whisker is going to go from Q3 all the way to the largest value, which is not an outlier. In this case, there are no outliers. The highest value is 48. It's going to go all the way out here to 48. Okay, there's our box plot. Now, that took a while. We can do box plots with the CAS calculator, provided that we have the raw data. And by the raw data, I mean the individual values in the data set. If you don't have the individual values, then you can't use the CAS calculator, which is why I took the time to do this example by hand so that you understand the mechanics of how to make a box plot from scratch. You are expected to be able to do all these steps. And they can test this knowledge, particularly in exam 1, which is the multiple choice questions. So you need to know everything on this page. For the purposes of actually doing the analysis, most of the time you won't do it by hand. You'll actually just get the CAS calculator to make the box plot for you. So now I want to show you how to do this. Again, you'll have seen this in year 11, but let me just briefly remind you how to do this. So you want to get your CAS calculator, create a new document, and you want to go to tab 4, which is lists and spreadsheet. What you need to do is give your data a name. So I didn't give it a context. So let's just call them scores, okay? So you type the name of the variable in the top row, and then down in the spreadsheet, you start typing in the values. So in this case, it was 26, 28, 32, 36, 38, 48. Okay, type in all your values. And now to create the plot, we need to go to a different window, and the keyboard shortcut is Control I. So press Control I on your CAS, and this menu will pop up again to create a new page. This time, you want to go to number 5, Add Data and Statistics. Now, this is not a box plot. What you need to do is go down to the x-axis and tap on this box which says click to add variable. So click on that. And this is why you needed to give it a name. Your name will appear there. And it will create a graphical display of your data. This is still not a box plot, it's a dot plot. We need to change it. So go to Menu, go to Plot Properties, or Plot Type, number 1, Plot Type, and then number 3, histogram, box plot, sorry. Number 2, box plot. And there you go, there's your box plot. And if we compare this with my picture, yeah, it's about the same. All right, let's do this one more time, and then I'm happy to sort of wrap it up there. All right, second example. We're going to do exactly the same thing. This time, I've given you a data set which is a little bit bigger, and I want you to do the 5-number summary and draw a box plot. You might want to actually pause the video and see if you can do this by yourself before I go through the solution. But here we go. How many data points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this time there are 9 values in the data set, and this is an odd number. Remember that if you want to find the median, the process is different depending on whether there's an even or odd number of values here. What you want to do to find the median is take the position n plus 1 all divided by 2, which is the 5th value. So the median is 36. Next, we want the quartiles. Now, when you have an odd number in your whole data set, I can't divide the data set into even halves unless I exclude the middle value. So this time when I do my halves to find Q1 and Q3, I'm not going to include the median. So Q1 is the median of the lower half, and that's going to be the mean of the middle 2 values. Similarly, to find Q3, I need the mean of the middle two values in the upper half. Okay, the minimum is 8. The maximum is 52. So the 5-number summary, remember, always answer the question that's asked. So if you ask for the 5-number summary, you've got to state it explicitly. And you've got to write it in order. So the minimum, Q1, median, Q3, maximum. Now, before we draw the box plot, we need to decide whether there are going to be outliers. So we need to calculate the interquartile range, the lower fence, and the upper fence. So let's start with the interquartile range. This is Q3 minus Q1. In this case, Q3 minus Q1 is 12.5. The lower fence is Q1 minus 1.5 times the interquartile range. That's going to be 26.5 minus 1.5 times 12.5. I'll need a calculator for this one. 26.5 minus 1.5 times 12.5 gives us 7.75. The upper fence is Q3 plus 1.5 times the interquartile range. Q3 is 39 this time. And if we do this calculation, we get 57.75. So again, no outliers. But if this number 52 was just a little bit larger, 58, it would be an outlier, and I would have to represent it as a dot on the box plot. So, let's draw the box plot now. And again, I'm going to need another page, so just bear with me. You don't have to actually write this, what I'm doing here, but I'm just writing it because I can only see one screen at a time. So 8, 26.5, 36, 39, 52. All right, we'll do the box plot down here this time. When you do your exams, you'll be given grid paper. So it'll be more precise than what I'm doing here. All right, so start with the box. Q1 is 26.5. The median is 36. Q3 is 39. No outliers. So our whisker is going to go from Q1 all the way down to the smallest value, which is not an outlier. So 8 is just slightly larger than 7.75. So there is no need to use a dot there. And similarly, 52 is not an outlier, so we'll extend the whisker all the way out here. Okay? All right, there's our box plot. I'll leave it to you to work through the exercise, and there'll be cases where you do need to draw the outlier. So remember, the whiskers, which are these lines coming out, they only go to the largest or smallest value, which is not an outlier. So you don't extend whiskers all the way to outliers. Okay, so if I go back to this first example here, maybe I'll annotate this. I'll say this here is the smallest value, which is not an outlier. And this value here is the largest value, which is not an outlier. Okay, so we've drawn two box plots in this video. I've got one quick example now of just finding the shape of a box plot. So you'll remember in our work on histograms that we had three terms to describe shape. They were symmetric, but because most of the time we are dealing with real-world data, there isn't perfect symmetry, but it's approximately symmetric. There is negatively skewed, and there is positively skewed. We had that for histograms, and now we want to be able to just use this language to describe the shape of a distribution represented with a box plot. So there are three box plots here. Let's label each shape. Group 1 is the straightforward one. This is the one that's approximately symmetric. Why? Well, on either side of the median, the distribution is the same. So the spread is the same in both the lower and the upper directions. Now, let's look at group 2. The question that I want to ask is, where is the spread larger? The spread is larger here. The spread is larger in the lower values or the negative direction. And that means it is negatively skewed. All right, this is the positive direction. Spread is much smaller. Negative direction, spread is much larger. And that means the last one is positively skewed. This time, the spread is larger in the upper values or the positive direction. Okay? Now, it's much easier to decide shape when looking at a box plot. Remember, with the histogram, it was kind of the opposite of what we thought. And that's why most of the time we kind of prefer to use the box plot. It's easier to interpret. And it's also easier to compare distributions from more than one group, as I have done here. And we will do that in a couple of weeks' time. Okay, so when we come back, the timetable isn't truly finalized yet, but this is what it's looking like. So when we have our first class, which is currently scheduled for Wednesday, I will start by giving you a quiz on the holiday homework. All right, there's a typo there, 1G. Wouldn't be fair to quiz you on material you haven't learned yet. So a quiz on all of the holiday homework, 1A to 1G, and I will be checking your books while you are doing the quiz. The quiz does not count to your grade. It's just to give you feedback. And if you completed your holiday homework very early in the holidays, that's fine. You might just have forgotten some of the material, so the quiz will sort of give you a refresher of what you might need to go over. And then in our next class, we will continue with chapter 1, and we'll cover the normal distribution, which is the 68, 95, 99.7% rule. And this year it's a bit more difficult, so we'll spend a full double period on just that one exercise. All right, that's all I've got for you. So I look forward to seeing you, Year 12s, in a couple of weeks. And remember, if you need any help at all, please do not hesitate to get in touch with me over Teams. All right, I'll see you soon.